Hello, here's an extra video, my first emailed screenshot. I feel like that's the best way to ask me a question is to take a screenshot of what you're working on and send it to me in my email, and then I can work on it and send a little video out. Okay, so the question was, how do you answer this question? And my answer, let's go through it. So hopefully it's fairly clear that with this, I'm asking you to create a tree diagram and label the probabilities in the tree diagram so that it shows you understand how multiple event probability works. So you'll remember that multiple event probability works by multiplying the events that happen. So there's one problem with what the student sent me here was that I can't read what the question asks exactly. And there's some really important language in the question. So I need to make sure that I do the question both ways, which is kind of perfect because now I can show both of the possible ways you'd want to answer this question. One way that I would answer this question is if the question asked a dependent probability. So if the question says anything about without replacement, so maybe the question asks, fill out the tree diagram with the probabilities if you take a marble out of the bag and then do not replace it. Something where it indicates that you're taking the first marble out and then you're setting it aside, and then that changes the probability for the second part of the tree diagram. The other way I could ask a dependent question is if I said, what's the probability of taking two marbles out at the same time? Oops. Okay, so that means that in order to take two marbles out at the same time, you need to consider that you would have to be taking two different marbles out. And so it's as if you're taking one out, not replacing it, and then taking another one. Okay, that leads me to the final way that I could say a dependent probability. Remember, dependent, different, denominator is if I said that I'm going to take two different marbles out. So if I ever say two different marbles or three different marbles or four different marbles, that would mean that I have to consider it a dependent situation. Okay, let's tackle this question as if it was asked in a dependent way. Looking at this bag of marbles, I can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have a total of 12 to start with. There's 4 green. Maybe I'll do that in green here. So 4, it's really big. 4 green. And then that would be 8 red. All right, so I'm just kind of keeping track of what's going on by taking a few notes here. So when we start a dependent scenario, it's the same as if we're starting an independent scenario because it's our first pick. So we're starting with a full bag of marbles, and so all of the denominators for the first part of our tree diagram, this part right here, they're all going to have a denominator that is the total denominator, which is 12. All right, and then for the red part of the tree diagram, what's the probability that you pick a red on the first try would be 8. And then for the probability that you pick a green on the first try, it would be 4 out of 12. So down here in the A, you would put 8 out of 12, and then you would put, for the green, you would put 4 out of 12 for that probability. Now, assuming, again, it's dependent, that means that we were taking one of the marbles out. So if what had happened on the first try was we got a red, then we need to consider that now one of the red marbles is gone. Okay, so that changes our denominator from 12. Now it's going to be 11. So on the second try of any dependent situation, you would take the denominator and make it go down by 1, no matter which marble was chosen, because it's always going to go down by 1. Now, let's take a look. What's the probability that we get red again? Well, we know that we no longer have 8 red. Now we have 7. So 7 red. However, we didn't change how many green marbles we had. We still have 4. So we would come down and we would fill in our C here with 7 out of 11. And we would fill out our green with 4 out of 11. Okay, now let's look at the other scenario. Let's look at the situation if we had instead gone this route. We had picked a green marble. What are the probabilities then? Well, in this case, one of our green marbles is gone. And so that means we no longer have 4. We now have 3 green marbles left. Okay, still 11 though, right? Because we still had 11, and it's because we still got rid of a marble, so the total goes down by 1. And then we still have 8 red marbles because we took out a green, not a red. Okay, so that means that here for this probability, we'd have 8 out of 11 red, and we would have 3 out of 11 green. So we could come in here and fill in these probabilities. This would be 8 out of 11, and then this would be 3 out of 11. All right, so that is if the language in the question lets you know that it is a dependent situation, that you're not replacing the marble when you go to pick your second marble. Now, let's erase everything we just did, and we're going to start again and pretend that we have an independent situation. So erase, 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 erase. Now, language in the question that makes you know that it's independent would be words where I'm indicating that you put it back. I think I had one question where I was trying to be funny, that you took out the marble, you licked it, and you put it back in. Okay. It's just anything where you have replacement. Or if I say you take it out, you record it, and you put it back in. So put back would be another way to say that. There's a lot of different ways to say that, but the idea is that after you take out your first marble, nothing changes. So each event is independent. The first one does not change the second. So the second event is independent of the first event. So again, the first part of our tree diagram is going to be exactly the same because we still have 12 total. We have 8 to start with for the red, and we have 4 to start with for the green. So let's fill out our first part of our tree diagram. Again, it's going to be exactly the same, out of 12, out of 12. The 8 is still the same for the red, and the 4 is still the same for the green. Now, independent is a lot less confusing because nothing changes for the second part. So just like I was doing when we were making those really, really, really big tree diagrams with much more complicated scenarios, I can just copy and paste the exact same probabilities, because that's what independent means. It means your probabilities don't change from event to event. So now, filling in the questions for this, we would just do the same thing over and over again. Might get a little repetitive, but it's 8 out of 12 for A, 4 out of 12 for B, 8 out of 12 for C, 4 out of 12 for D, 8 out of 12 for E, and again, 4 out of 12 for F. Just a quick note so that you guys are aware, to find the actual probability, like if the question had asked you, what's the probability of green and then green again? Independent or dependent, you can look up at the tree diagram and take the two probabilities. Green is the example that I'm doing right now. And you just multiply them together. So it would just be 4 out of 12 times 4 out of 12 if you have an independent scenario. And if you remember back to the dependent situation that we did first, this had changed to 3 out of 11. So remember that in a dependent scenario, the denominator always goes down by 1. Dependent, different denominator. But in the situation that we are viewing right now, it would be this, and then you multiply, turn it into a percent, and you're done. I hope this helps you, and keep the questions coming. I'm serious. Just email me anytime. I'm happy to do it. I love doing math. That's why I chose this job. So please, please, please keep up the great questions.